So today we started with this problem. Y equals 2 plus the sine of 2x minus pi. And you'll see this sometimes in my math lab or in the textbook. And they also talk about the standard form. And one of the things that we need to remember with the standard form is we like seeing the plus k on the end. So the first thing I did was move the 2 over. Now, the second thing to get it in standard form was we had to pull the period out. So whatever the coefficient is of x, in this case it's 2, we had to divide both of these by 2. Divide this by 2, it gives me just the x. Divide this by 2, I get pi over 2. So now I'm in standard form. Questions on that? Questions on that? Because that's a step that a lot of people can forget, is to divide that out. Actually, this is 2. Okay, now I remember I had defaults, right? My h and k, if there's 0, I don't move up or down, but there's still something, there's still a number. My b, that was my period. If my b was 1, I didn't do anything. And if my a was 1, I really didn't do anything either, the a being the amplitude. So the first part of this was to identify the values for h, b, a, and k and tell me what they do. Well, I'm going to come back over here and I see x minus h, x minus pi over 2. That's pretty easy. Pi over 2, it's positive, we move to the right. The next one, my period, that's my b. My current period is 2b. So this guy, to find the period, is 2b over, 2 pi over b, because my current period for sine is 2 pi. I'm going to divide it by b, and when I do, I say, oh, yep, now there's a period of pi. The a, there's no a out here. I don't know why I wrote it. It's just 1. A is just 1. And I know that's one of my defaults, so I don't have any graph to worry about there. K is 2 up 2. So I'm going to need my parent. I'm going to need an h, a b, and a k. I'm going to need 4 graphs. If you got pi over 2 to the right, a period of pi, a is 1, k is up 2. Give me a thumbs up on your screen so I know. This is a quickie. I need to see what's going on. All you thumbs up. 1, 2, 3, 4, 5, 6. Good. Good. At least half the class got it. And if I hopefully gave you another one that you all would get it, I'm just curious who left. I know some people were having internet problems. But you're going to see a bunch of problems like this on the test. Identify the H, B, A, and K. H back. Remember when it was just college algebra, there was no B, it was hack. Okay, so now I need the graph. I'm going to start with the parent function. Y equals the sine of x. You're going to do these over and over and over and over. So memorizing is going to be natural. It's just going to hopefully come to you. And, you know, sine is here, up and down. So again, this goes back to that unit circle. And if I'm thinking the unit circle, sometimes I'm not sure. But if I said, hey, what's the sine of pi? I don't remember from the unit circle, but there it is. The sine of pi is 0. The sine of pi over 2 is 1. So I could get some of those values I might need by knowing a different representation of the values. And that's this graph y equals the sine of x. Okay, the next one, I'm going to take my h into play. I'm going to move the whole thing to the right, pi over 2. So what was 0 is now pi over 2, dot. What was pi over 2 is now pi, dot. What was it pi is now 3 pi over 2, 2 pi, and oh, ta-ta. I think it looks pretty good so far. Next thing, make the period, oh, wrong way. Make the period pi. So I start here and everything. So instead of going from pi over 2 to 5 pi over 2, I now have to go from pi over 2 to 3 pi over 2. So I know it needs to start at pi over 2, and I know that it needs to end by 3 pi over 2. So this is going to be a 0, this is a 0, this is halfway, it's a 0. Have to get up to 1, down, down, and up. So I shrunk it. Okay, the last thing, I need to move everything up, pi over 2. This is not the best. It should be from here and back down by pi, which is there, and down and back up. That is definitely not good on my part. Should have gone from pi over 2 to 3 pi over 2. I need white out. Don't look at that. Look at this. Up. What was at 0 is now at 2. What was at 1 is now at 3. By pi, I should be back down to 0. By pi over 3, I should be up to there. I messed up. 9 out of 10. Questions. I love when I get questions. I just don't get them. Okay. Hopefully you're good.
I got a question.
Yes.
What do you call H? What's the name for that?
Horizontal shift, left and right.
Okay.
The sun sets on the horizon. This is the horizon. Johnny, question.
Yeah, so when you did the shrink, what did you multiply by to do the shrink again? Was it just a 2x? So that would be 1/2 then? So then you just multiply the pi?
Right, because if you look up here, my period for sine is 2 pi. So my new period is going to be 2 pi divided by whatever that b is. So 2 pi over 2 reduces to just pi. So what did take me 2 pi now has to be done within pi. So I start at pi over 2 and I finish by 3 pi over 2. So it took this bad boy and it shrank it.
Gotcha. Thank you.
Good questions. Okay, the one thing that wasn't covered here is the amplitude. And I'm going to do another amplitude type problem. And I'm going to make up a function. It's not one of my parent functions. It's just one I'm making up. And let's say I have a value here at 1, a value here at 2, or at 1 up to 2, and then a value of 2 is down here at -1. Okay, and that's my function. And it could be something that looks like squiggle, 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 squiggle. I don't care what it is, just some goofy shape. Now the amplitude was my A. So if I said y equals 2 times that mess, that means f of x, we know from our function notation, is my y. So this means I'm going to take my values after I calculate them and double them. So if I'm doubling all the values here, I'm now going to have a graph that at 0, this guy was at 1. So at 0, this guy is now at 2. When I was at 1, this thing was up to 4. So here's 4, and I had sort of a curve shape. So what was at 1 is now 2. What was at 2 is now up to 4. And when I got out here, I ended at -1. So now that gets doubled, and it should be down at -2. So now I'm going to have this squiggle part go down. So my y's get doubled. What was at 1 is now up to 2. What was at 2 is now up to 4. What was at -1 is now down to -2. Squiggle, 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 squiggle. Okay, so that A, that amplitude, doubles my y values. And you have something like that on the assignment sheet. Someone had asked a question about that. I said I would make sure I covered it in class today. Any questions? Okie dokie. Do. Section 3 and section 4. Well, in the first two sections, we talked about the sine and the cosine. And then we went crazy doing all the translations. Well, what we're going to look at today is the other four trig functions, the secant, the cosecant, the tangent, and the cotangent. And then we're going to monkey around with one or two of those to see what we would get. So I have this paper here. If you want to put it on, I'm going to put it on another piece of paper just so I can make it big enough so you can see what's going on. All right, I'm going to start with the sine of x. Here is 1. Here is -1. I'm going to come out here to pi, and I have 2 pi. And if I was to graph the sine, I'm getting really good at graphing the sine. I know that it looks like this. And I'm going, woohoo! Pencil, y equals the sine of x. All right, so the next one we're going to take a look at is the cosecant. Y equals the cosecant of x. I should have made it red instead of blue, but it'll work. Y equals the cosecant of x. In fact, I'm going to shall I clean some of this out so you can't see? Now, how are the sine and the cosecant related? R word.
It's the
Reciprocal?
Reciprocal, right? They're reciprocal. So if I want to take a look at the graph of the cosecant, I'm going to take a look at the y values and do the reciprocal. For example, what is the reciprocal of 1? Right here. This is a y value. I want the reciprocal. What's the reciprocal of 1? Well, if this guy, if the sine of x is 1, the cosecant of x has to be the reciprocal. Reciprocal of that is 1 over 1. What's 1 over 1? 1, right? So I know that's a point on the graph of the cosecant of x. I have another value here, 0. If the sine of x equals 0, what's the reciprocal? 1 over 0? Can I have 1 over 0?
It's undefined.
It's undefined, right? Which means the reciprocal of 0 doesn't exist. It's undefined. I'm going to make that a dashed line. And that dashed line is called, it's called
Asymptote.
asymptote. Asymptote. Asymptote. Okay. So it's undefined. Oh, here's another one. Got it. Okay, cool. There it is, right? I have these asymptotes every pi. Pi, 2 pi, 3 pi, 4 pi, -pi. I got asymptotes all over the place. I got the reciprocal of 1 is 1. The reciprocal of -1 is -1. If I said 2, its reciprocal is 1/2. Agreed? It's getting smaller. If I said 3, it would be 1/3. If I said 4, so as I start getting those values and I do the reciprocal, it gets smaller. But what about the reciprocal of a smaller number? Like what if I said 1/2, which is here? What's 1/2's reciprocal?
2,
What's 1/5's reciprocal?
5.
5.
1/10's reciprocal. Okay, so what happens is as these values from my sine get smaller, and they're all less than 1, their reciprocals get larger. And that means I'm going to get a graph for y equals the cosecant of x that looks like so. And y and all of these negative values, when I flip those, I get like so. So by drawing the sine graph first, and I could say, I'm gonna really kind of hide it now because I did it in pencil, and that's cool. I get the graph of y equals the cosecant of x. Do I memorize this? Nope. Do I know the sign because I've drawn it a million times? Yep. Which means if I can draw the sine graph, I can quickly go asymptotes, 1 is 1, up, -1 is -1, and down. So now I can start to fill in some information about this. The domain is going to be the real numbers except, well, how do I want to write this? Pi, 2 pi, 3 pi, because that's all of my asymptotes. And really, it's usually written as any integer times pi, any integer times pi. That's where my asymptotes will be, and you see it written like this, or there's a letter N that represents integer. So that's my domain. My range, well, my range for sine was what's between 1 and -1. My range for cosine is going to be -infinity down to -1, including -1. Union with 1 all the way up to positive infinity. And usually infinities, we just put a round one. So it's everything from -infinity to -1, and then from 1 to infinity. To infinity and
Beyond.
Beyond.
thank you, thank you. All right. Thanks for playing along with that. Well, now if I took a look at y equals, y equals the cosine of x, see what I've learned without having to look back up above. The cosine of x, I know that at 1, let's not go up so high. Let's go, 1 is here. I have -1. Okay, I had my pi, I had my 2 pi. Sine is really familiar, but I'm getting there with the cosine because I've done it. And I'm doing the homeworks and I'm drawing it, and the cosine looks something. So, well, yeah, something like that. And now I'm going, okay, so if that's the cosine, I'd like to see the graph of its reciprocal, which is the secant. And right away I'm going, okay, secant. Yeah, because there's a 0. Yeah, I got that. And I know the -1, yeah, that's going to flip because the small numbers become large numbers. This is going to come down and touch there. This is going to go here and up to there. Just like the last one, again, the period is 2 pi. I didn't mention that up here. I should have. Period equals 2 pi. Because from here to there, and then it will start to repeat. Same with down here. From here, it goes up, it does this, and then it comes back down to 1. So again, the period is 2 pi. Nice. Domain, that's the same as up above, except it was all real numbers except pi over 2, 3 pi over 2, something like odd pi over 2. You write it however you want. I don't care. It just shows your understanding. The domain is all numbers except pi over 2, 3 pi over 2. The next one would be 5 pi over 2, and so on. Finally, the range is going to be just like this. -infinity to -1, union with 1 to positive infinity. And again, we were talking about all these early on, which was good because now we're using them. Now I have the cosecant and I have the secant, and I'm happy. Okay, two more. Y equals the tangent of X. Y equals the tangent of X. That's just awful. That's just awful. One of the things I know about Y equals the tangent of X, it's rewritten as this ratio sine of X over cosine of X, right? Yeah, that sounds about right. Here's 2 pi. Here's negative pi. Got something. So this is important because whenever the cosine is 0, I can't divide by 0. So I'm going to have another one of those asymptotes. I think I had the cosine over here, didn't I? When was the cosine itself 0? I'm going to come back over here and do it. When was the cosine 0? Let's see, the cosine did one of these numbers, right? This was pi. This was 2 pi. The cosine was 0 at these locations. The cosine was 0 at pi over 2. At 3 pi over 2. At negative pi over 2. Okay, so we have that much information. My next bit of information is the sine. When was the sine 0? Not that I'm dividing by 0, but it'll be the fact that it would be 0 over anything. And according to this, the sine was 0 at 0. So I know that's one of the points on my graph. At pi, it's 0. At 2 pi, it was 0. Okay. Now we could keep doing research and finding some things out, but once you see the graph of the tangent, your biggest thing is going to be remembering where were the asymptotes. It was when the cosine was 0. Where are the zeros? It was when the sine was 0. And once I have all this drawn, I'm going, okay, he told us once, he doesn't have to tell us again. That's what the tangent graph looks like. That's what the tangent graph looks like. Now, some things to note about this. First of all, how long do I go before I start to repeat? I'm going to write this in red. It's important. From negative pi over 2 to pi over 2. Then I repeat in red, big letters, period, equals pi. Oh, so this is totally different than what we've seen before. And remember on this sheet, when we did this fella, and we said, given b, we do 2 pi over b. Well, what's it going to be up top if my parent function is tangent? Don't all scream at once.
Pi.
Pi, thank you. It's going to be pi. So we would be using pi over b in that situation. All right, if I had to write the domain, it's going to be all real numbers except these guys. And that was pi over 2. Yeah, that's that whole odd pi over 2, except all the odd pi over 2. And the range is going to be, everything, all real numbers. The big thing here is, how did I come up with a graph? I did my asymptotes when the cosine was 0, pi over 2, 3 pi over 2. I did my zeros when the sine was 0, that's the numerator, and I graphed. And all of a sudden I said, wait a minute, we go this far before it repeats. And that far is only period. Woo, one more parent function. You all know what it is. Y equals the cotangent of X. And written as a ratio, it's the cosine over sine this time. So where are my asymptotes going to be? When the sine is 0. Okay, so here's pi, here's 2 pi, here's negative pi. When is the sine 0? This was my sine graph at 0 at pi. So now this time I have asymptotes here, 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 and so on. So I did my asymptotes first, my divide by 0 problem. Now my zeros are going to be when the cosine was 0. That was pi over 2, 3 pi over 2, negative pi over 2, all of those values. And my graph, well, the best way I can say to help you remember this is the cosine is the reciprocal of the sine. So think of this guy flipped. Yeah, flip him real good. Yeah. And you have the graph of the cotangent. Once more, what's important? Period equals pi. So for the tangent and the cotangent, the period is pi. All right, so yeah, I gave you spots on this sheet to draw all that. I wanted to draw it all out, make it a little bit bigger. Maybe you did it on here, but you're then going to do a clean copy over here and so on. One thing you can do is go on the internet. And I found this on the internet. Here's the sine of X. Yeah, here's the cosine. Yep, there's our tangent. This one is the flip of this one, right? The cosecant from 0 to pi, is the flip of the sine. The secant is the flip of the cosine, and then we had the tangent. So all that's put on one sheet. I don't know if that's something that you'll use, or will you use your work that we just used for this? I don't know. So we have 4 new parent functions. The rest of our trig functions. So now we have 6 of them. So now we take a look. Let's see what the graph of y equals the tangent of 2 times the tangent of x is. Let's see if I follow protocol H, B, A, and K, and you know my standard form would be y equals A, the tangent of B times x minus h plus k. So if I wrote this underneath, I see A equals 2, H is 0, that's my default. B is 1, that's a default, and K is 0. So this is the only one I have to graph other than the parent function. So now I'm going to have practice. My tangent had asymptotes at pi over 2 and negative pi over 2. Yeah, there's my parent function. Y equals the tangent of x. So this time, all I am doing is doubling my y values. Again, that's what the amplitude does. It doubles my y values. My asymptotes are still at pi over 2 and negative pi over 2. But my y values, well, 0 doubled is still 0. This looks like it may have been about at 1 when I come over there. So I'm thinking that now it might need to be up and go something like that and something like that. You notice how it's a little skinnier than this guy, more narrow. It's growing faster. My Y values all got doubled. Cool? No, I can't stand math. I hate math. No, you don't.
I have a question.
Yes.
I don't know what the questions are gonna look like on the test, but so are the only way, basically, how do we signify this better than just drawing it? Because my drawings are pretty garbage, right? So like the left graph is gonna look pretty close to the right graph. Are we just kind of looking for A?
Yes, that's the difference between, and I'll be looking at you identified A as 2, and you'll be done. On the test, you're gonna get a lot of this. Tell me about H, B, A, and K. Because to do these actual graphs is hard. But on the assignment sheet, you're gonna see that there are multiple graphs to show this translation.
Okay, I got you.
I hope there's more. Me too. Here's one. You know what I'm gonna do right now? I'm gonna put you back in breakout rooms. So the first thing I need to do is pause the recording. Okay, so my original equation was y equals a tangent b x minus h plus k. And I wrote y equals -3 tangent parentheses 1/2 because I pulled the 1/2 out. X minus, that stays 0 plus 1. H 0, don't have to graph it. That was my default. B is 1/2. Remember, we're dealing with the tangent. So this is pi. Pi over b, divide by 2 is the same as multiplying by the reciprocal, da, 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 da. I have a period of 2 pi now. My A is -3. So that means the Y values are going to triple, and then they're going to flip. When my amplitude was a negative, it flipped. Finally, my K is 1. So I'm going to do my parent function, my B. I'm going to do the A of 3 first, then flip it, and then my K. Parent function, Y equals tangent of X. Yeah, awesome sauce. The next thing I do is I'm going to make the period become 2. So what's going to happen here is 0 is still going to be 0, but my period is going to be 2. So what was at pi over 2 is now pi. What was at -pi over 2, my other asymptote, because I always do my asymptotes first. And I also make sure they're labeled, right? I know that this is -pi and that's pi. So now my graph should look something like that. It got the wider. The next one, the Y values get tripled. Asymptotes, -pi, I see it. +pi, I see it. My values grow faster. So instead of there, I'm going to go there and down that way. Next thing I'm going to do is flip it. Flip it real good. This point still exists, and I know it's still in that fast mode, and it eventually will get over to those asymptotes. It's just not there yet. And last but not least, I'm going to move it up 1 because I like to move it. Ta-da. Okay. Questions? Final comments? Yes,
It's actually pretty simple. It's just a matter of repetition.
you betcha. You got it. I have a quick question. In the last class, we talked about odd and even functions. Would this be odd or even? Now let's see, I need to go back and remember what odd and even are. Y equals x squared, this was y equals x squared. That 2 was an even, and even functions, I can flip around the y-axis, right? It's symmetrical over the y-axis. Which one of these is even? Which one of these, if I folded it over the y-axis, I'd have the same thing? Like if I bent the paper and I folded right on the y-axis, the one side would go right on top of the other side.
Cosine.
Yeah, it's this one, it's the cosine. And then the other thing we talked about, and again, this is, that repetition again. This was y equals x cubed. It was odd, it was an odd function. And in order to get it, I didn't flip it over the y-axis. I didn't flip it over the x-axis, but I took the origin and I rotated everything 180 degrees and laid it on top. And that's going to be true for the sine. I would take it, and if I lifted this up and rotate it and put it back down, it would land right on top of itself. It would be an odd function. Terminology that we've seen before, and it comes into play here again. All right. A little bit more of chapter 4 on Wednesday. Not much. Test is on Monday. Whew. Next Wednesday, we're almost halfway there. Are there any questions on anything today? All righty. If not, I'm going to stop the recording.